In this video, I want to talk about how our trig functions, sine, cosine, tangent, cosecant, secant, cotangent, all those types of things, got their name. And we've looked at these before. This is just something I was reading recently, and I thought it was interesting to share. So I wanted to make this short video just to kind of give you some more information on things that we use all the time, but we may not know where the names come from. And as if we know where these names came from, I think it will help understand a little bit more. Now, first thing I want to do is I want us to think about the graph of sine. So if I'm going to graph sine, the graph of sine, and I'm just going to put this into my calculator, and the graph of sine looks like that. Some of you know that, some of you have seen that before, right? So if you know that graph, that has to do with where that name comes from. And the word sine comes from Latin, where sinus means curve. And there's some connection between medieval Latin and going back to Arabic. But the idea, the most important part for us right now is that curve comes from this Latin word meaning sinus. So obviously by looking at the graph of sine of x, it's curved. And we may not understand also that when we use sin, sine of theta, that's really a shorthand for sine with an e of theta. So really this is a graph of sine of theta with the e. Shorthand, we just do sin of theta or x or wherever we're looking. Now, let's continue on then. That's where sine comes from. It means curve. Now, let's consider the complement of an angle. If we have 40 degrees, the complement of it's that, remember, complement means adds to 90, would be 50. So the complement of 20 would be 70. And some of you might see where this is going. What about the complement of sine? Or we could shorten that to the cosine is the complement of sine. Now, what does that mean? Well, consider the sine of 40 degrees. And if we just put that in the calculator, we get 0.64. Well, what's the complement of 40 degrees? 50. So what is the cosine? What is the complement of sine of 50? The exact same thing. So cosine really just means the complement of sine. Sine of 20, 0.34. So what is the complement of sine? The cosine, which would be the cosine of 70, the exact same thing. So when we think of sine meaning curve, cosine just means the complement of sine. Now, what about our other trig functions? So let's look at these for a second. First, define some words from geometry. If you remember, if you have a circle, and you're going to see we're going to end up at our unit circle. If you have a circle, the tangent to a circle is this line that intersects at exactly 1.90 degrees to the radius. And then a secant of a circle is a line that goes all the way through the circle. So we're going to use those ideas to define what is our tangent and secant. So let's look at our unit circle. So here I have a unit circle. I have a circle where the radius of this circle, I did this like in the Geometry Sketchpad program, GeoGebra, is 1. So that's my AC. So we are on the unit circle. And if I look at my point C, we know that the sine of C is just the y coordinate. That is this y coordinate here. And you can see I have this set at 40 degrees. And when I measured this on Geometry Sketchpad, I got 0.64. And if we put sine of 40 degrees, we get 0.64. We know that the cosine of this angle is just the x coordinate. So the complement of sine, or the cosine of 40, is 0.76. Once again, down here is our answer for the cosine of 40. That's just our x coordinate. Now, here's where it gets interesting. Imagine for a second we drew this line right here that is our tangent line. And then we measured the distance from here up to here, where if I extended this line through my unit circle at 40 degrees, I get this distance right here from B to D, or D to B. This distance here is 0.84. Well, if I take the tangent of 40, I get 0.84. It's this distance from here. It's the distance of this angle to the tangent line. Our sine was the y coordinate of that angle where it hits the unit circle. Our cosine is the x coordinate of where that angle hits the circle. And our tangent is if we draw the tangent all the way out there, that distance gives us our tangent. So you can see there's actually a physical representation of what all these trig functions mean. Now, our last one. If we look at this line here, this secant line that goes all the way through the circle, this line here is from A to D. And the measurement of that angle, of that line, A to D, is 1.31, which you can guess, if I do 1 over cosine, which is the secant of that, I get 1.31. So you can see all of these words: sine, meaning curve; cosine, meaning the complement of sine; tangent, which comes from the tangent to the unit circle; the secant, which comes from a secant line on the unit circle. This is where we've gotten all of these terms. We're used to just calculating these by just throwing in the calculator or looking at something like that. When these words were first being invented or first being used, they were coming from this geometric idea of our unit circle and of the measurement that you could take from the unit circle. Obviously, cotangent, complement of tangent; cosecant, complement of secant. So all of these words are coming from our unit circle and the idea of what the complement of an angle is. So now, just a short video here, just to give you some more math history, explaining where the names of our trig functions come from.